Once again, welcome you to the Bridge Structural Analysis webinar today. I'm Nikhil from Midas, and today we are going to have a brief understanding of the Bridge Structural Analysis, and this webinar is specially intended for Canadian engineers. So let us start with the webinar. If you have any questions in between the webinar, please feel free to post them through the chat window, and I would take up all the questions towards the end of the webinar. On your screen now is the schematic diagram of the Moore Canyon Bridge, and you can see the construction stage, how this bridge is going to be constructed in concept, and the structural analysis of this bridge was performed, and now I'm going to show you how the structural analysis results look like. So on your screen now are the results of structural analysis of this particular bridge, and you can see the displacement or the deformation profile in different stages. As you can see, this bridge is an underslung cable structure. It requires geometric nonlinear analysis, and hence geometric nonlinear analysis was performed in different stages so that we can obtain the desired results after performing the finite element analysis. Moving ahead, let's talk about the Nelson Creek Bridge. On your screen now is a diagram or an animation of the Nelson Creek Bridge, in which we have performed the response spectrum analysis in X direction, and also the response spectrum analysis is performed in the Y direction. Talking about the Alexandra Bridge, you can see the deformation profile of the Alexandra Bridge in the vertical direction, and also in this bridge, the seismic analysis was done by the engineer. Finally, let's talk about the Calgary West Light Rail. And here you can see the bridge, which is a section of the West Light Rail in Calgary. And you would see how the bridge is constructed in different segments. And I have created an animation for you so that I can show you how this bridge was constructed in different stages. And in the next slide, I have put in an animation for you where you would appreciate how the finite element analysis is being done in different stages so that we can obtain the result forces or the result after performing the finite element analysis in separate stages. So here on your screen now, you can see the different stages of the construction of this particular section of West Light Rail, and you can see how the finite element analysis is performed in individual stages and the results are obtained. The reason why I'm showing you these animations and these results from finite element analysis is I would like to tell you that since we are approaching towards more and more economic design and we want our structure to be safe at the same time, we need to perform finite element analysis on our projects, whatever type of projects we are working on. So today we are focusing our technical discussion on bridges, so that's why I took up the examples of bridges. But whatever sector you are working on, if you are working on geotechnical structures like foundations or tunnels, or if you are working on buildings, high-rise buildings and all, it is important to perform finite element analysis so that you can ensure that the structure that you're designing is safe in all respects. And with the help of these animations, I've shown you how you can easily perform finite element analysis to obtain the results in several stages. And everything that you saw so far, the finite element analysis and the animations, everything has been done using Midas Civil. Midas Civil was the program which was used to perform analysis on the animations on the bridge projects that you have seen so far. So today we are going to discuss before you how Midas Civil can be used by the Canadian engineers in their projects. We have developed Midas Civil a lot. We are working in accordance with MTOs and all, and we are developing Midas Civil so that it can be used, it can be adapted by the Canadian engineers. So today, with the help of this webinar, I'm going to show you what all we have got for the Canadian engineers in Midas Civil and how you can use Midas Civil for performing finite element analysis on the bridge projects you are working on. So first of all, let me give you a very brief introduction about Midas Civil, what Midas Civil is all about. So Midas Civil is a finite element analysis software. It works on the theology of finite element analysis, and you can perform 3D finite element analysis in Midas Civil. It's a general purpose software. You can model not only bridges, but if you are into like plant structures or subway structures, you can do that in Midas Civil. And generally Midas Civil is used by structural engineer to perform analysis on different structures he's working on. And as you can see in this particular animation, Midas Civil can be used to perform analysis on bridges, but not only bridges, you can use Midas Civil to perform analysis on underground structures as well. And this shows you the example of underground structure, which is a tunnel, shotcrete lining, and Midas Civil has been used to perform analysis on this particular type of project too. And Midas Civil is not only an analysis tool, but it has got design features too. So if you are, if you want to perform design as per Canadian code, you can do that in Midas Civil. Let me share with you the list of our clients in North America, and on the screen in front of you, you would see the list of our clients in North America. You can see that various governmental organizations such as Ministry of Transportation Ontario, British Columbia Ministry of Transportation, they are working with our software for their bridge projects. Not only that, the DOTs in US like Oregon Department of Transportation, Caltrans, the California Department of Transportation, Florida Department of Transportation, they are all working with our software for their bridge projects. Big names such as AECOM, HNTB, Delcan, SNC Lavalin, All North Consultants, they are also using our software for their bridge projects. Talking about bridge projects specifically in Canada, here you can see in this particular slide the clients we have in Canada. So here again you can see that governmental organizations such as Ministry of Transportation Ontario, British Columbia Ministry of Transportation, and Yukon DOT, they are working with us. And talking about the private consultants, Associated Engineering, SNC Lavalin, AECOM, Delcan, CS2M Hill, All North Consultants, MMM Group, they are all working with Midas Civil for their bridge projects. So you would appreciate that Midas Civil is being used by big design firms such as SNC Lavalin or AECOM in Canada. Today I have divided this webinar into 4 different sections, and I will be talking about these 4 items in front of you as far as Midas Civil is concerned. First of all, I'm going to talk about several project applications in which Midas Civil has been used as the prime analysis software or the design software in Canada and US. Then I'm going to talk about how Midas Civil can be your tool for performing finite element analysis on several bridge projects, whatever type of bridge project you are working on. Then we're going to talk about how Midas Civil is Canada code friendly. What are the different features of Canadian code that we have implemented in the new version of Midas Civil. And finally, we are going to talk about the consulting services which are offered by Midas along with the softwares it provides. So let me first start with the project applications in the projects which have been done in Canada using Midas Civil. You can see on your screen now, I have shown you 4 different project examples in which Midas Civil has been used as a prime analysis software, and these are some of the pilot projects only. And if you want to see the complete picture, there would be several bridges which are being constructed, which have already been constructed, and analysis have been done using Midas Civil. So I've just shortlisted 4 of them for you. Again, if you want to see the projects which were done in United States with Midas Civil, you can see them on the screen which is in front of you right now. The US 17 Wilmington bypass, the Leroy Selman flyovers, and some more projects here. So basically Midas Civil has been used in a variety of projects. With these project examples, you must have seen that Midas Civil has been used not only for segmental bridges, but it has been used for truss bridges or conventional bridges as well as for cable stayed bridges. So now I'm going to talk about how Midas Civil can be your tool, how you can use Midas Civil as your tool for any type of project that you might come across while you are working in your organization, or whatever type of project that your organization might take up. So first of all, let me talk about the graphical user interface of Midas Civil and how Midas Civil would be proved effective in your work. Basically, whenever you talk about any finite element analysis software, ultimately at the end of the day, what you need is result. Whatever type of analysis you perform, if you perform construction stage analysis, time history analysis, static analysis, geometric linear analysis, etc., at the end of the day, you want results so that you can, check the structure, design the beam, etc. In Midas Civil, we have introduced a very intuitive graphical interface. It's so intuitive that you would be able to learn the software in no time. The learning curve in Midas Civil, it's very steep. You will pick up the software in no time. And not only that, once you are done modeling the bridge, you can check whether the modeling that has been done by you is perfect or not by virtually moving inside the structure. So with the help of this animation, I hope you guys can see the animation on your screen. And with the help of this animation, you would see that I am moving inside the bridge and I'm checking whether all the modeling that I've done for this particular bridge, is it fine or not. So this is how you can check the structure, and this is how you can utilize the graphical user interface of Midas Civil for your projects. Now let me talk about the different type of bridges and how you can use Midas Civil for those type of bridges. First of all, let us talk about conventional bridge. Here you would see that in Midas Civil we have a wizard based model generation, and all you have to do is put in what is the span distance, how many different type of spans that you have, so as you can see, in Midas Civil we have the wizard based model generation for conventional bridges. All you have to do is punch in the information for different spans, whatever number of span that you have for the conventional bridge, and put everything, all the details in Midas Civil wizard, and the wizard will automatically generate the model for you. Let me now go to Midas Civil itself and let me show you what do I mean when I say that you can create anything with the help of a wizard. So let me open Midas Civil in front of you and let me show you how you can easily create the finite element model of conventional bridges automatically with the help of the wizard. So on your screen now is the work window of Midas Civil, and as I said, I would like to create a conventional bridge model using the structure wizard that I have. So here I would go to the conventional bridge structure wizard, which is RC frame box culvert bridge wizard. And here what I'll do is I will specify what are the different spans in this bridge and what is the dimensions. So all these dimensions you will punch in here, and you will tell the program what type of conventional bridge it is. Is it a normal type frame or a pi type frame or a box culvert? And then you can define the transfers, how the transfers looks like, and then you can define the different type of loads that you want on your particular bridge. So here you can specify the load combinations. If you want the load combinations as per the Canadian code, you can select the Canadian code. If you want the load, if you want the self-weight to be included, check on the self-weight. If you want the underground water pressure to be included, you can do that. And if you want the program to consider the temperature loading as well, you can check on the temperature loading. And once you click on OK, Midas Civil will automatically generate the bridge model for you. So here I have clicked OK, and you would see that the bridge model is generated in no time in front of us. So it's very simple. You can model these conventional bridges very easily in Midas Civil, and whatever definition that the wizard has done, it will be listed here in the works tree. So you can see the different loads that have been applied. You can see the different boundaries that have been applied by the wizard. And not only the straight bridges, but if you want to model skewed bridges as well, you can do that with the help of these wizards. And the model which is generated using these wizards is perfect as far as the finite element modeling is concerned. So you don't have to worry about whether this finite element model is correct or not. You can just use this finite element model and go ahead, run the analysis on it and obtain the design results. Talking about the steel composite bridges, which is another type of bridge widely constructed throughout the world. Here you can see that in Midas Civil you can simulate the different construction schedule of this bridge. You can consider the composite as well as the non-composite stages, and you can model the cross frames in 3D in Midas Civil. So I have created some animation so that I can show you the different stages, the non-composite and the composite stage, and you can also appreciate the cross frames which have been modeled in 3D in this particular bridge model. Again, to sum up, talking about the steel composite bridges, in Midas Civil you can simulate the non-composite as well as the composite stage. If you want to perform the full 3D finite element analysis using the shell elements, it is also supported. And if you want to perform the soil structure interaction, you can model the foundation as well, and you can model the soil springs, and you can perform soil structure interaction in Midas Civil. If you are working on integral bridges, Midas Civil can help you with that too. You can model the soil spring support automatically. All you have to do is punch in the soil data, what is the type of soil that you have, what are the parameters of the soil, and Midas Civil will automatically generate the soil supports for you so that you can perform analysis on integral bridges. So you can perform soil structure interaction on integral bridges. Now let us talk about another variety of bridge, pre-stressed concrete bridges, and see how Midas Civil can help you with those type of bridges. So again, for pre-stressed concrete bridges, we have got certain bridge wizards that you can use, and once you are using the bridge wizard, you can generate the model in no time. 3D models, you can create 3D models in Midas, 3D tendons in Midas Civil, and not only you can create them, but they can also be created automatically if you are using a wizard. And if you want to make some tweaks after you created the model with the help of wizard, you can do that. You can, once you run the analysis, you can obtain the tendon losses. Both instantaneous tendon loss and the time-dependent tendon loss can be obtained from Midas Civil, and you can simulate the construction schedule, and you can obtain the results of time-dependent behavior of concrete in terms of creep and shrinkage. So now let me take you to Midas Civil itself, and let me show you another bridge wizard for pre-stressed concrete bridges. Again, on your screens now is the work window of Midas Civil, and now we're gonna see the bridge wizard for pre-stressed concrete bridges. And here we have multiple bridge wizards for that. So we have the full staging method type of construction bridge wizard, and once I click on this bridge wizard, you will see that all you have to do is specify the span lengths, what is the material that you are using for a particular bridge, and if it is a curved bridge, you can check on the radius and you can define the section. If you want to use the database section, good enough, you can use the database section, but if you want to use your own section, you can use your own section too. Then you can specify the tendon parameters, what is the location, crude location of the tendons, and once you click on OK, Midas Civil will automatically generate the bridge model in front of you. So basically, all you need to know is what is the span length and what type of section you are going to use for your bridge, and Midas Civil will automatically generate the bridge model for you. And let me show you the supports in this particular bridge model. It's a 4-span continuous pre-stressed concrete bridge constructed span by span, and let me show you the construction stages. So this is the first construction stage of this particular bridge, second construction stage, third construction stage, and fourth construction stage. So basically the wizard will not only generate the finite element model for you, but it will also generate the construction stages for you. And let me show you how the tendons have been modeled in Midas Civil. So here you can see the tendons have also been modeled, and these tendons have been modeled in a very engineering manner. You can see that the tendons go up at the mid supports, and at the mid spans they go down. So based on the bending moment profile of this particular construction type of the bridge, the tendons have been intelligently put in by the wizard. The importance of using this type of wizard is that you can perform parametric analysis on your bridge structure. So you can compare a variety of cross sections in no time. All you have to do is punch in the cross section in the wizard, and the wizard will generate the model for you based on the span lengths. And you can create multiple models in no time. So you can choose the best section, you can choose the dimension of the section, you can increase or decrease the top flange or bottom flange thickness. You can tweak with the tendons, whatever number of tendons you are using in your bridge, and basically you can make a more optimized design. You can do more optimized design with the help of these bridge wizards, because they help you in creating the model very easily and very quickly. Now, talking about the segmental bridges, some of you must be interested in segmental bridges because when we talk about higher end of bridges, segmental bridges, uh, we talk about segmental bridges. And in this particular slide, I have shown you how Midas Civil can be used to perform analysis on segmental bridges. So here you can see that again for segmental bridges, we have different wizards that you can choose. And once you select the wizard, Midas Civil will automatically generate the model for you. Not only the model, but Midas Civil can also model the 3D tendons for you. Construction stages will be automatically modeled as I have just shown you, and you can take into account the time dependent effect. And basically all type of segmental construction is supported in Midas Civil. So if you are designing balanced cantilever type of bridges, you can do that. If the bridge that you are designing is incrementally launched, you can do that. So basically whatever type of segmentally constructed bridge you are working on, Midas Civil can be used to perform analysis on the same. And in this animation, you can see how this analysis of this particular bridge, the modeling of this particular bridge is being done in Midas Civil. Now let's talk about the high-end bridges. And when we talk about high-end bridges, we talk about the cable bridges such as cable stayed bridges or suspension bridges. In Midas Civil, again, we have certain features that you can choose to perform analysis on these type of bridges. You can perform geometric nonlinear analysis on cable bridges. Midas Civil can automatically generate what is the cable pretension in the cables as per different stages, and the most important of them is you can perform forward construction stage analysis in these bridges in Midas Civil, and you can take into account the time dependent effect. So you won't leave anything on the construction site engineer. You can simulate everything beforehand. Before you submit the drawings, you can obtain the camber diagrams and everything. You can put into the design sheet what should be the appropriate camber for individual segments once they are being laid by performing proper simulation, precise simulation in Midas Civil. So basically Midas Civil can be used to perform analysis on all type of bridges that you might work on. And here you can see that you can perform analysis on conventional bridges that I've already shown you, culvert, frame bridges, slab bridges, precast, splice girder bridge, integral bridges, all supported. You can perform analysis on those type of bridges. Talking about the staged segmental bridges, as I've shown you, you can perform analysis on any type of construction methodology for staged segmental bridges, be it a balanced cantilever type of construction, incremental launching method, etc. And finally, if you are working on mega structures like cable stayed bridges, extra doors bridges, or suspension bridges, you can use Midas Civil for those type of projects too. So now let us talk about the main feature of this webinar, and here we are going to talk about how Midas Civil is Canada code friendly, because you would not just use the software for like modeling purposes, but you want it to be customized for your own code. And this is exactly what we are in the process of doing. We are working closely with MTOs. As you can see, like major DOTs, major MTOs are our users, and we talk with them on how we can improve the software for their purpose. And still we are in the process of developing certain other features that might be helpful for you, but till date whatever we have, let me share with you. So first of all, let me talk about the modeling features. There are different modeling features that we have as per the Canadian code, and here on your screen you can see that you can define the material as per the Canadian standard. So you can see if you talk about the steel material, we have a whole list of steel material that you can choose from. If you talk about the concrete materials, again we have the list of concrete material that you can choose from as per the concrete code of Canada. Not only that, several big firms must be working for projects in states as well as some other part of the world, and we have in Midas Civil the material and section database for other codes as well. So if you are willing to work in another country, you can use the database of that country to define the material as well as the section properties. Now let us talk about the section properties. What are the different type of sections that you can define as per the Canadian code? So here you can see that we have the database of different sections as per the CISC code, and you can select different type of cross-section profiles such as I section, angle section, channel section, and you can click on any of the names here. You can select any of the section name, and the parameters of that section will be automatically taken by the program. You can see on the right and the left that I have selected an I section and an angle section as per the Canadian code. So when we talk about the pre-stressed concrete sections, there is generally no database sections that you can choose from because the codes generally do not specify different sections. So in Midas Civil, what we have done is we have provided you a list of different type of sections that you can choose from. So if you want to define a 1 cell section, a 3 cell section, or an n cell section, you can do that in Midas Civil. You can specify what are the parameters of top flange and bottom flange, and the box section will be automatically defined for you. When you are working with pre-stressed concrete bridges, it becomes, sometimes it becomes annoying if you don't have these kind of database sections to choose from. And if you are performing parametric analysis, again, this might become a bit of a task if you have to import the section every time from AutoCAD. So we have the database of sections for general bridges, but if you are working with a very different type of cross section which is not available in the database of Midas Civil, that you can import the section from AutoCAD. So now let me take you to Midas Civil itself, and let me show you how you can easily define the material properties of the section properties as per the Canadian code. So I'll go to properties here in the work window of Midas Civil, and I'll go to material properties, and once I click on add, you can see that I can select the standard as concrete standard, the Canadian standard, and you can select the material from the database. And here you would see that the properties will be automatically taken by the program as per the standard. And if you don't want to use these properties, you want to tweak with them, you want to change, you want to work with the modified properties, then you can very well work with the modified properties by specifying whatever property you want to use. Similarly, you can go to the concrete code and you can select Canadian standards and you can select the code from the database. Now let us talk about the section definition. So when I go to the section tab here, as I said, you can select different type of sections to work from. If you want to define an I section, select an I section. If you want to define a channel section, select a channel section. So here I've selected an I section and I selected the Canadian code for it with SI units, and once I tap on any name, you will see that the parameters are automatically taken by the program. So it's very simple. If you're working with I sections which are in the database, which are in the standard, then you can quickly select them through the database of Midas Civil. Now, as I said before, when it comes to pre-stressed concrete section, here you will see that we have a different type of pre-stressed concrete sections that you can choose from. You can define 1 cell, 2 cell, or n cell pre-stressed concrete sections. You can define what are the parameters of different items here, and once you define these parameters, the section will be defined for you. So that was all about how you can select the database material and cross sections in Midas Civil for Canadian code. So let us now talk about general modeling principle, because these things are I mean, when I talk about the material or the cross section database, these things are specific to the code. But now let us talk about the general modeling features of Midas Civil, because the modeling features, the general modeling features will not be according to any code, they are common to all codes. So let me just give you an idea about the general modeling features. So as you can see here, when you are working with the post-tension box girder bridges, you would see that at the mid supports we have higher depth of the cross section as compared to the mid span or any other place in the bridge. So in Midas Civil, what you can do is you can first create the same cross section at all the locations, and then you can use one of our wizard features, and with the help of these wizard features, you can change the depth of the cross section. So this is how it looks like. I defined the same profile of the bridge all through, and then the section dimension has been changed automatically by the program. Again, when you're working with pre-stressed concrete bridges or post-tension box girder bridges, it becomes a tedious task to define the tendon properties, the tendon profiles. So here, if you're working with any ordinary finite element analysis software, you have to punch in several coordinates of the tendon, and then the tendons can be defined. But in Midas Civil, we have got new techniques of defining tendon profiles. As you can see here, we have different reference axes that you can choose from. If you have a curved bridge, which is the most difficult bridge for modeling the tendons, you can use the curved reference axis or the element reference axis, and then you can define the tendon in those reference axes. If you want to define the tendon in your inclined webs, then you can use the x-axis rotation angle. What you can do is you can define the tendon in the centroid of the cross section, and then you can use the x-axis rotation angle to rotate the tendon and make them in your inclined web. So this is how you can do it. So it becomes very easy. We have certain specific features that you can choose from for modeling the tendons, and it will become very easy once you are working with Midas Civil. Now let us talk about the Canada code-friendly analysis features that Midas Civil provides you with. First of all, let me give you a basic overview of different analysis features that Midas Civil has. So apart from general static analysis, linear static analysis, you can perform construction stage analysis considering the time-dependent behavior of concrete. You can perform moving load analysis. If you want to perform inference line or inference surface analysis, you can do that in Midas Civil. You can perform eigenvalue analysis. Dynamic analysis is supported. You can perform large displacement analysis, P-delta analysis, or buckling analysis. And we have got a separate set of advanced analysis features in Midas Civil. So you can perform thermal stress analysis, heat of hydration analysis, nonlinear analysis in terms of material or geometric nonlinearity, and you can also perform pushover and fiber model analysis. So basically, all type of analysis that you might need for performing, for obtaining results on the bridge structure that you might design are available in Midas Civil. Now let me talk about the moving load analysis, which would be customized as per the Canadian code. So as you can see here, in Midas Civil, you can select the moving load analysis code as Canada, and once you select this code, you can select the various vehicles from the Canadian standard, and we have increase the database of vehicles that you can choose from. We have introduced the British Columbia state database vehicle, and here you can also, as you know that the dynamic load allowance factor that will be defined as per the Canadian code has been changed recently. So in Midas Civil we have implemented that. Now you can either ask the program to calculate the dynamic load allowance automatically as per the old code, and if you want to use the new code by defining the dynamic load allowance by yourself, you can go to user input and you can define the dynamic load allowance by yourself. And we have also provided a new vehicle in Canadian moving load analysis, and in this particular vehicle type you can define more than two wheels in a particular axle. So if you are performing analysis for moving loads on bridge which are supposed to carry the vehicles which have more than two wheels on a particular axle, then you can use this type of vehicle and you can perform analysis on it. And once you perform analysis, you can obtain a variety of results for moving loads in Midas Civil. And if you have chosen the automatic definition of dynamic load allowance, then you can obtain what is the dynamic load allowance used by the program by asking the program to give you a detailed result for the same. So I'm gonna let me go to Midas Civil itself now, and let me show you how you can work along with in Midas Civil to perform moving load analysis as per the Canadian code. So again, we are on the work window of Midas Civil, and this time we are performing the moving load analysis. So I'm going to go to the load tab of the ribbon menu here, and I'll go to the moving load. Straight away, I will select the Canadian load, the Canadian code here. And if you are working on projects in other countries, then we have different other codes which we have implemented here that you can choose from. So straight away, I'll select Canada, and once I select Canada, I can define the Canadian vehicle. And here you can see the different Ontario trucks as well as the British Columbia truck. So you click on any truck and you can define, the truck will be automatically defined for you. When we specifically talk about the British Columbia truck, you will see that the distance between the third and the fourth axle is variable, and Midas Civil takes care of that thing. You can define the variable distance between two axles, and Midas Civil will automatically adjust the distance between the two axles to obtain the worst case scenario for you. So as I said, we have introduced a permit truck type of loading in Midas Civil Canadian moving load analysis, and now you can define more than two wheels in a particular axle. Let me demonstrate to you with the help of an example here. So I selected a vehicle, and here you would see that in axle type A3 we have 8 wheels in a particular axle. So this is how you can define it. So if you are working in projects which have more than 2 wheels in a particular axle, you can use this dialog box to define the vehicle type. Now let me show you the result features as per the moving load analysis of Canada. So I have already performed the analysis on this particular bridge type. So if you want to perform, if you want to obtain the results, you can go to result, forces, beam diagrams here, and you can obtain the results for the same. And here you would see that we have categorized the results as MV max moving, which is the maximum sagging bending moment profile, the envelope for the moving load analysis. MV min is for the maximum hogging bending moment. So let me show you the MV max, which is the maximum sagging bending moment, and this is how the envelope of maximum sagging bending moment looks like. And the maximum hogging bending moment, this is how it looks like. Now let me take you to a very special feature for Midas Civil for moving load analysis. And here in this particular feature, what you can do is you can select any element and you can ask the program what is the location of the vehicle for obtaining the maximum bending moment in terms of sagging or hogging bending moment. So basically it gives you a check whether the moving load analysis is being performed precisely by Midas Civil or not. As I said, you can obtain the dynamic load allowance from the program. So here you can click on the detailed result, and once you click on the detailed result, Midas Civil will tell you what is the dynamic load allowance as per the Canadian code if you have selected the auto definition of dynamic load allowance. So this is how you can obtain the dynamic load allowance if you have selected auto in the vehicle definition. Again, let me show you the vehicle definition. So here you can see that I have used the auto input, so the program will give me the dynamic load alliance once I perform an analysis. But if I want to use my own dynamic load alliance factor, then I can go to user input and I can perform analysis based on these dynamic alliance factor that I have defined. Now, as I said before, Midas Civil can be used to perform construction stage analysis considering the time-dependent behavior of concrete. You can define the time-dependent behavior of concrete as per a variety of code, as here, and you can perform time-dependent material analysis. If you're working on rail projects, you can perform rail structure interaction analysis in Midas Civil. And we have, in the new version, we have introduced a rail track wizard with the help of which you can automatically generate the model for rail structure interaction. As you know that once you are, you want to perform response spectrum analysis, rail structure interaction analysis for rail bridges, you have to do multiple definitions, and it is like a mechanical process. So with the help of this wizard, we have reduced that mechanical process, and you can automatically generate the links that you need for performing the rail structure interaction. You can perform the dynamic soil structure interaction analysis in Midas Civil, and here you can define the nonlinear point spring supports. And as I said, Midas Civil can automatically define the spring supports for you you can just put in the soil parameters, and Midas will automatically define the soil support for you. And you can also define the nonlinear hinges for performing dynamic analysis. You can define hysteretic systems, etc. And you can perform time history analysis so that you can obtain the effect of earthquake on your bridge structure. So now let me take you to Midas Civil itself, and let me show you some of the result features pertaining to construction stage analysis in Midas Civil. So again, we are working with this project, with this model that we generated using the wizard for span by span construction. So let me show you how the bending moment diagram appears for different construction stages. So I'll go to construction stage 1, and I will see the bending moment diagram due to dead load, and this is how it looks like. And once I move to other construction stages, I can obtain the bending moment diagram for other stages. Not only that, if you want to see the effect of creep or shrinkage, you can do that in Midas Civil. You can obtain the construction stage results for a variety of load combinations. You can see that we can obtain the effect of dead load, tendon primary load, tendon secondary load, creep primary, creep secondary, etc. So basically we have distinguished between the different type of effect on the bridge, and you can obtain the results for these individual effects in construction stages. Now let us talk about tendon results, what type of tendon results that Midas Civil provides. So here, if you go to the result tables, you can obtain the tendon loss in the tabular format. So this is the tendon loss in the tabular format, as you can see on your screen now. And here it would show you what is the instantaneous loss in the tendon, what is the elastic deformation loss, and what is the creep and shrinkage loss, and what is the relaxation loss. And the best part is you can obtain these losses in a variety of time intervals for any tendon. So here you can change the construction stages from 1 to 5, and you can obtain what is the tendon loss after 150 days. You can define another construction stage for, let's say, 1000 days, and you can obtain what is the tendon loss after 1000 days. Another sweet thing about Midas Civil is that you can obtain the tendon coordinates, and you can supply that coordinate table to the site engineer so that the tendons can be placed at the required locations. Now talking about the substructure, Midas Civil can be used to perform analysis on the piers. You can perform analysis on piers, and you can obtain the PM interaction curve, MM interaction curve, as well as you can obtain the stress profile generated in the cross section. So here you can select the Canadian code as I have demonstrated here in this particular slide, and you can obtain the PM interaction diagram 3D or 2D with as per the Canadian standard. So let me quickly try to open one of the projects that I have done using Midas Civil for obtaining the PM interaction curve as per the Canadian code. So this is how it looks like, this module which generates the PM interaction curve. And basically the best thing is you can create a link between Midas Civil and this particular module, and once you perform analysis in Midas Civil, the load combinations will be automatically transferred to this particular module so that you can obtain the PM interaction curve and whatnot. So once you go to option, you can go to design code. You can select the design code as per the Canadian design code here. And as I mentioned earlier, if you're working with other country codes, you can also select other country codes, and then you can design the section. After you design the section, you can obtain the interaction curve. So this is the PM interaction curve, the MM interaction curve, and you can obtain that in 3D also. You can obtain the moment curvature curve too. This is how the moment curvature curve looks like. And you can also obtain the stress contour in this particular type of profile. So here it shows you what is the stress in concrete. If you want to obtain the stress in rebar, you can check on rebar. You can obtain the stress in rebar, and you can see how the mesh looks like. So basically with the help of this module, you can obtain what is the stress in concrete, and you can create a link between Midas Civil and this particular module to obtain the results for the same. Now let us see how the Canadian code has been implemented for design in Midas Civil. So first of all, let me talk about the pre-stressed concrete design features. Very recently in Midas Civil, we have introduced the design feature for pre-stressed concrete in Midas Civil, and here you can select the design code you can select the Canadian design code, and you can obtain the check for the following. You can obtain the flexure resistance check, the shear resistance check, and you can also obtain you can check the service limit stages also. So all you have to do is step one. If you want to perform the design, it's very simple and straightforward. Step one is defining the load combination as per the Canadian code so that you can then check it. And here you can see that the Canadian that I have generated the automatic load combination as per the Canadian load by the automatic tool in Midas Civil. Then you can tell the program what is the material that you are using. So here again I would select the material as per the Canadian code, and finally I can perform the design to obtain the result. So let me again take you to Midas Civil itself, and let me show you how you can perform the design in Midas Civil for pre-stressed concrete using the Canadian code. I see that there is a lag between the screen transfer, so let me wait for a while so that everybody comes at the same page, and then I will start working with the design features. Okay, so I'll go to Midas Civil once again, and here, as I said before, for performing the design, the step one would be the definition of the load combinations. And for defining the load combination, I would go to the result menu here, and I will go to load combination, and I will go to concrete design, and I will ask the program to automatically generate the load combination for me. And here I will select the Canadian code. As you can see on your screen, I have selected the Canadian code here. And once I click on OK, the various load combinations as per the Canadian standard, they have been automatically generated. You can see the different load combinations for strength limit state as well as the service limit state here. So after this, we'll go to the PSC design tab, and we will ask the program to do the design as per the Canadian code, and we will set up the parameters. We will set the design code as the Canadian design code, and the type of output parameters, and the environmental exposure. So what type of material you are using, if you are using de-icing chemicals or you are not using de-icing chemicals, you can specify that. And we have two options to give you the flexural strength. You can use the code calculations as per the code, and if you want to use the strain compatibility, you can do that. So basically sometimes the engineers prefer the strain compatibility approach for obtaining the moment of resistance. You can do that in Midas 7, and you can also obtain the flexure strength as per the code. And then I'm going to define the design material for pre-stressed concrete as per the Canadian standard. And once I do this, I'll hit on perform design, and Midas Civil will perform the pre-stressed concrete design. And after it performs the design on all the elements which are present in this particular model, it will show you the results, and it will show you what elements are safe as per Canadian standard for PSC design and what are not. So please give it a minute and it will perform the design. Okay, the design is performed, and here we can obtain the results. So you can go to result tables and you can obtain the flexure result check. So I went to the result tables and I went to the flexure check, and here you can see everything which is okay is termed in black. You can see the check as okay, and if it is not okay, then it will be shown in red. So whatever is shown in red is not good, and the engineer gets to know that something is wrong in this particular section, and you have to make some changes to make it safe. And you can do the shear strength check, you can do combined shear and torsion check. If you want to check the stress in the cross section in stages as per the code, you can see that. So here Midas Civil will give you what is the stress and what is the allowable stress as per the code. And if it is in red, that means it is not good and you have to do something about it. Not only that, if you want to obtain a detailed calculation report for the design, you can click on Excel report, and Midas Civil will automatically generate the Excel report for you. And I happen to have one Excel report generated with Midas Civil which I want to share with you. So on your screen now, you should have an Excel report which is generated using Midas Civil for performing design as per the Canadian standard. And you can see that the detailed calculation report has been provided, and the various codal equations along with the sections have been provided in this particular design sheet. So this design sheet, you can use it as a reference to perform design, and if you want to put some parts of it in your final design report, you can very well do that. So basically the idea of providing the design features in Midas Civil is that you can perform parametric design again. You can generate the model using the wizard, define the moving load as per Canadian standard, perform the design, and check whether the structure is safe or not. So this whole exercise, it won't take too much time. So in a small time you can perform parametric analysis on so many type of bridges as you want. So basically it's all-in-one software. You can do the modeling with the wizard, you can define the moving load analysis as per the Canadian code, then you can perform the design also. So it will help you in performing parametric analysis on different type of cross sections. You can also perform a design on reinforced concrete section as per the Canadian standard, and this is how it looks like, the design reports. Now let me talk about how Midas Civil can act as a consultant for you if you want to perform finite element analysis on bridges. Midas Soft, we not only believe in providing a good software to our clients, we not only believe in developing the software as per the needs of the clients to make it more customized for our clients, but we also believe in providing support so that they can use, so that our clients can use the software in their projects. And here you can see that we provide free project support. So you can work along with our engineers and they can help you in developing the best finite element model. We can do customized trainings with you. We can help you one-to-one for performing finite element analysis on your projects. And I know that some of you must be spending a lot of money in outsourcing the finite element analysis projects. You must be paying the consultants a huge amount, which can be like half of the project cost and everything. So if we are doing everything for you, we can share your finite element analysis work with you, and all of this is done with no additional cost. And in Canada specifically, we have certain successful examples. I personally have worked with SNC Lavalin, and we have provided them extensive support for their bridge projects, and another in Assured Engineering, MTOs, All North Consultants, MMM Group, and the list is ever growing. So if you become our client, we will do everything to make sure that we provide you the best support, the best assistance as far as your finite element analysis is concerned. And towards the end, I would like to talk about how you can learn Midas Civil quickly. So basically Midas Civil, as I said before, we have a very intuitive user interface that you can learn very quickly. The learning curve in Midas Civil is, you can learn it in no time. And Midas provides free training service. And once you get our software, if you want to evaluate our software, we provide free training. We provide online and offline training. We can provide a visit training to your company also. And not only this, on a large scale, Microsoft organizes various seminars. So there are two types of seminars that we organize. We generally set up a seminar place. We invite engineers from all across the country to talk in that bridge seminar or whatever type of seminar we are doing, and it shows you a list of different places where we have organized the seminar so far. And the most latest was organized in New York. It was known as the New York Bridge Seminar, and we invited several consultants from HNTB, Parsons Springerhoff to talk so that the engineers can share the technical expertise with each other. And not only that, we also do online technical seminars, and we have been inviting engineers from several consulting firms such as HNTB, Parsons Springerhoff, and other big names such as Parsons, MMM Group, etc. You can see some of the engineers from Canada here, MMM Group, Assured Engineering, etc. Not only that, we invite engineers from DOTs or MTOs to talk on our technical seminar so that they can share with other engineers for the recent design practices in terms of bridge engineering. And at the same time, we also invite professors from universities so that they can talk about the recent advancements in the terms of engineering. So these are the services that we provide, along with providing one of the best finite element analysis softwares to you guys. So I would like to thank you all for being with me in the seminar today. And in conclusion, I think with the help of this 50-minute session, I have talked about how you can use Midas Civil for your bridge projects and how you can utilize the services provided by Microsoft so that you can perform finite element analysis on your projects. And side by side, our other engineer was answering some of your questions, but if you still have some questions that you want me to answer, please let me know through the chat window, and I will be more than happy to assist you with any of your questions. And we have recorded this session, so if you want a recording of the session, you can ask for it. We can provide you the recording of the session. And if you want to ask specifically about any particular type of bridge, we can very well do a presentation with you.